I'm back. Let's see how you guys did. So let's take a look at the predictions for potential energy. Where on here did you think there would be the lowest amount of gravitational potential energy? Well, hopefully for your lowest, you said either 2 or 5. Let me scooch myself over so you can see. Because these are the places where our roller coaster is going to have the least amount of height. So the lower that you are, the less potential energy you would have. Now, looking at this, 2 and 5 look like they're at exactly the same height. So that would indicate that they have exactly the same amount of potential energy. So for our actual, we're going to go ahead and put 2 and 5, and I just want you to write that these are actually the same. Those are actually tied. So the next, well, that would be the next highest position, which would be position 3. And then next highest from there would be position 6. Next highest is position 4. And then next highest is position 1. All right, now let's talk about kinetic energy. So this is going to be wherever we're moving the fastest. Well, we would expect that at the very beginning, at this top of this ramp where we've just been just barely being released from right here, we actually come to a stop at the top before we start going down, that would be where we were moving the slowest. And so that's going to be where we have our lowest amount of kinetic energy. And then as we go down, you guys saw when we did the activity with the skateboarder that he would have the largest amount of kinetic energy at the very bottom. And while there's 2 places where we're at the very bottom, and that's again 2 and 5. And what do you think? Would they be the exact same amount of kinetic energy? Would they be a little less? I don't know. If we imagine that there is in fact friction on this roller coaster, if it's a realistic roller coaster, then probably 2 is going to be a little faster because by the time you get to position 5, that car's been going over more of the track and that's been turning into thermal energy and causing it to slow down. If we imagine that this is frictionless, then 2 and 5 would actually be the exact same amount. Remember what happened when we turned the friction off versus turned the friction on with our simulation? That's exactly what would be happening here. If there's no friction, 2 and 5 are the same. If there is friction, then 2 would be a little bit faster. We're going to go ahead and assume that there's no friction in this particular roller coaster to keep things simple. So when we talk about our highest positions, I want you to go ahead and put 2 and 5 and say that they are the same. And you might put a little note for yourself, no friction. Okay. So if there was friction, 2 would actually probably be a little faster than 5. Okay. So then let's kind of, I think, maybe work our way backwards. Where would be the next fastest? Well, probably right around 3, where we're starting to go up this loop. We're going to start to lose a little bit of our speed as we go up. Then we're going to be losing some more speed by the time we get up here, but we'll probably be going a little faster at 6 than we would be at 4. So then 6, and then finally 4. So you can see that basically this is the exact reverse of what we had up here, where these are the same, and then it goes 1, 4, 6, 3, 1, 4, 6, 3. Exactly the same on either side. All right, next I'd like you to take a look at a couple of these questions. So this says, at the beginning of the ride, the roller coaster is at the bottom of the hill and is not moving. So, right here. Now the track is actually 5 meters off the ground. Oh, you couldn't see that, sorry about that. So the track is 5 meters off the ground. So what we're trying to say here is that this height right here, right there, that is 5 meters. So what I want you to assume is that each of these squares is considered 5 meters. So up here, this would be like 5, 10, 15, 20, 25, 30, 35, 40, 45 meters high. Okay, so each of these is 5 meters high. And so then it ends up 45 meters high, right? 5, 10, 15, 20, 25, 30, 35, 40, 45, yeah, okay. So that's 45 meters high. So how far would we actually have lifted? I want you to think about that. Okay, so at the bottom of that hill, when the roller coaster is not moving and is 5 meters off the ground, I want to know what kind of energy does that roller coaster have? So please take a minute and think about that, and I'll see you in a second.